Today we're covering Lesson 6 in Unit 11. So we want to be on page 368 in the textbook. You need the textbook pages 368 and 369. It'd be very helpful if you had 4 colored pencils or pens. And the graphing calculator is somewhat optional. We can use it to check our work. Your homework is going to be in the textbook, pages 370 and 371. So our basic graphs of sine and cosine. Our sine and cosine functions can be graphed by using their values at the quadrantal angles. Remember, our quadrantal angles are angles of multiples of 90 degrees, like 90 degrees, 180, 270, 360, and so on. Most trig graphing is done with the input angle in radians, though. So let's convert these degree measures to radians. Hopefully you recall that 180 degrees is equivalent to pi radians. Twice that, 360, would then be 2 pi radians. 90 degrees would be half of 180, or pi over 2 radians. And 270 would be midway between 1 pi and 2 pi, which would be 1.5, or we write 3 pi over 2 radians. Consider the functions f of x equals sine x and g of x equals cosine x. Okay, I'm going to use, when I do the graphing on this page, our f of x, I'm going to use red for our sine function. And g of x, I'm going to use blue for our cosine. So it would be helpful if you did the same. Where x is an angle in radians. So we want to complete the unit circle, or use the unit circle to complete the table below for selected quadrantal angles. Well, let's look at a diagram of the unit circle. So I'm just going to draw an x and y axis and mark the 4 points. Before I write in their coordinates, I'm just going to have my parentheses and the comma separating the x and y coordinate. Now we know that when we are working with the unit circle, the x coordinate is the cosine of the angle, and the y coordinate is equal to the sine of the angle. So my x coordinate I'm going to fill in blue. So this would be the point 1, 0, using red for my y coordinate, at 90 degrees or pi over 2 radians. This point would have coordinates 0, 1. 180 degrees or pi radians, this point, -1, 0. And at 3 pi over 2 or 270 degrees, 0, -1. And let me just go back and put the angle measures as radians. So this is 0 radians, pi over 2 radians, remember is equivalent to 90 degrees, pi radians, 3 pi over 2 radians, and in one full circle, 2 pi radians. So first, cosine x, using the blue. Cosine of, and I'm starting at 0 in the middle of the table. Cosine of 0 radians is 1. Of pi over 2 radians is 0. Of pi radians is -1. 3 pi over 2 radians is 0. 2 pi radians is 1. Now go clockwise. Negative pi over 2, 0. Negative pi, -1. Negative 3 pi over 2, 0. Negative 2 pi, 1. Now switch to the red pencil and let's fill in the table for sine. Starting at 0 radians, the sine of 0 radians is the y-coordinate, 0. The sine of pi over 2 radians, 1. Sine of pi radians, 0. Sine of 3 pi over 2 radians, negative 1. And of 2 pi radians, 0. Now let's go around clockwise. Negative 1, negative 1, 0, 1, 0. Negative 1, 0, 1, 0. Now from the table, now we want to graph both the sine and cosine curves. Graphing cosine first. Okay, so we have our radian measure, our x scale, labeled with our radian measure. The y doesn't have any scaling, all right, noted. So these are going by ones. Right? If there's no scale noted, then your scale is 1. So let's just plot the point. 0 radians, the output is 1. Pi over 2 radians, the output is 0. Pi, negative 1. 3 pi over 2, 0. 2 pi, 1. Connect these with a nice smooth curve. Negative pi over 2 radians, 0. Negative pi radians, negative 1. Negative 3 pi over 2, 0. Negative 2 pi, 1. What do you notice about this? What type of function is cosine? It seems to have symmetry with the y-axis, which it does, all right? So this is our cosine, so this is g of x, let's label this g of x equals cosine x. And this is an even function. Recall even function from unit 7. Even function. Symmetric with the y-axis. Switch to the red pencil and let's plot the points for our sine x. The sine of 0 radians is 0. So sine starts at the origin 0, 0. Pi over 2 radians, it's at a height of 1. Pi radians, 0. 3 pi over 2, negative 1. 2 pi, 0. Connect these points with a nice smooth curve. And then our negative x values, let's see, negative pi over 2, we're down at negative 1. Negative pi, 0. Negative 3 pi over 2, negative 1. Or excuse me, 1. And negative 2 pi, 0. Let's label this f of x equals sine x. And this has symmetry with the origin. Okay? It says symmetry with the origin. If we was to turn this 180 degrees, our red graph would be the same image as what we started with. So this is an odd function. The domain and range of our sine and cosine functions are the same. This is just for our basic sine and cosine function, right? What value what's the coefficient of our g of x equals cosine x, right? What's in front of that? What's the coefficient? It's just 1. The same here. F of x equals, this would be a 1 sine x. So this is our basic sine and cosine without any transformations applied to it. The domain is all real numbers. Right? The domain is all real numbers. It says to state them in interval notation. So domain would be, let me just use my purple neutral color. Negative infinity to positive infinity. The range remember is low to high. Domain was left to right. And it has to be the lowest number first, right? Each one has a low output of -1. After how much horizontal distance will both sine and cosine repeat its basic pattern? Okay, well the pattern here for cosine, right? It started at 0, 1, went down to the x-axis, then down to -1, then came back up to the x-axis, and then back to where it started at the height of 1 where it started. All right, so this is considered one complete cosine cycle, and its horizontal distance is 2 pi. And this is called the period. So the period is equal to 2 pi. And that's the same for sine also. You want to keep in mind what your basic cosine function looks like. If I'm just looking at the positive values for cosine, it's going to start at 0, 1. At 2 pi, it will end at that height of 1. Midway between, at pi radians, it would be down at -1. So max, between the max and the minimum value, it's going to be on the x-axis, and between the min and max crosses the x-axis. So this is our basic cosine. It kind of looks like a teacup. For our sine, our basic sine graph, again, if I'm just focusing on radian measures from 0 to 2 pi, sine starts at the origin. Starts at the origin. One cycle at 2 pi, it's going to be at a height of 0. It's going to be on the x-axis. Midway between, it's on the x-axis. Between 0 and pi, it would get up to a height of 1. And between pi and 2 pi, midway between would be at -1. So this is more of an S shape, kind of a laying down S shape. Cosine starts at 0a. Start at 0, 1. Okay, so now we're going to look at changing that a value, changing that coefficient. Next, we will see the effect of changing the coefficient, the a value, in the trig function. We're going to graph functions of the form y equals a sine x and y equals a cosine x. So with number 2, the graph of y equals cosine x is shown. All right, so that's in black. And we know that cosine, let's see, do I have a black pencil here or pen? I do. Cosine, our basic, This is what is graphed. Y equals cosine x is in black. Right? It starts at 0, 1. At 2 pi, it's up at the height of 1. At pi, it's down at -1. All right. I'm going to color code these. There are 4 different graphs that we want to put on this one grid. So I'm going to go blue, red, green, and purple. And hopefully you have some colored pens or pencils at home and you can do the same. We don't need the calculator for this, to do this. So if you don't have your calculator at home, that's fine. We're going to use what we recall from transformations. So if we have y equals cosine x, the coefficient here of y equals cosine x is 1. And it started at the point 0, 1. It ends at a height of 1. So y equals 3 cosine x. What do you think the point it'll start with? It should start at 0, 3. Remember when we did our transformations, right? This 3 here is outside the function. It's 3 cosine x. When the coefficient was outside the function, it was a dilation. We saw it as a dilation of 3 to the y coordinate. So let's take our point 0, 1, take the y coordinate 1, multiply it by 3, and you get 0, 3. I'm going to go to the start and then to the end. Take this point here at 2 pi comma 1, take the y coordinate 1 multiplied by 3, and we're at 2 pi comma 3. These two that are on the x-axis, their y coordinates are 0. 0 times 3 remains 0. This point here, pi comma -1. Take -1 times it by 3. That's -3. We said that our cosine function is even. So let's take this point, reflect it over the y-axis. Take this point, reflect it over the y-axis. And connect these. So there we have, by hand, a graph of y equals 3 cosine x. What's the range here? Low is -3, high is +3. Switch to the red pencil. Y equals -4 cosine x. It's going to start at 0, -4. Right? If I take this point, the y value is 1, times it by -4, and I'll be at -4, 0, -4. If it starts at 0, -4, then at 2 pi radians, it's going to be down at -4. And midway between at pi, I can go back and take this point, pi -1, take the y coordinate -1, multiply by -4, and we're at +4. Simple. And now reflect over the y-axis. To get the other piece of our graph. Our range, -4 to +4. Y equals 3/2 cosine x. It's going to start at 0, 3/2. let me just take my blue pencil or pen and go back up to y equals 3 cosine x. It started at 0, 3. 0, 3 halves. That's midway between 1 and 2 here. It's going to start there at 2 pi. It's going to be at that same height. And midway between those two maxes, it's going to be down at negative 3 halves. Reflect over the y-axis, so this jumps over to here, this to here, and these stay. So you do y equals negative 2 cosine x. Oh, I apologize. Let me go back and let's fill in our range from negative 3 halves to positive 3 halves. You can tell me the range of y equals negative 2 cosine x before you even start. We know it's going to go from negative 2 to positive 2. And it will start at 0, negative 2. Reflect over. Now, we didn't use the calculator at all. If you're going to use the calculator to check, okay, first off, you have to be in radian mode. And if your calculator has been cleared, right, the default setting is radian, so you're fine. Key in to y equals. So just to save time, I have y equals 3 cosine x in y1, because that's going to graph in blue. Negative 4 cosine x in y2, and my y3 is black, so I put in cosine x. And then it says to zoom 7. So then you press the zoom key, and then you can arrow down to number 7 or press the key 7. So there's the blue. That's y equals 3 cosine x. You see that it is starting at 0, 3. And then negative 4 cosine x is starting at 0, negative 4. And then the black is our y equals cosine x, which would start at 0, 1, right? Because the coefficient there is 1. The only thing with these calculators is that when the x window, the window for x is going from about almost negative 3 pi to positive 3 pi. So you have a little extra that you're seeing. If you just count the first 4 tick marks, 1, 2, 3, 4, all right, and stop there, that is going from 0 to 2 pi. So you have a little extra on the end here. If you don't like seeing that extra on the right-hand end and then the same little bit of extra on the left-hand end, then you would press Window and have your X min go from, you just put negative 2 pi. Remember, pi is second caret key. So negative 2 pi, and the X max to positive 2 pi. So just 2 pi. And now if I press graph, then that will match the window that we have on our notes page exactly. Right? So this would match up exactly. You can get the lighting better here. Because now this matches. This is going from 0 to 2 pi this way, and 0 to negative 2 pi that way. Okay, so the A coefficient, the coefficient, what's in front of our cosine function in that case, controls the height that the cosine curve rises and falls above the x-axis, right? The -4, the red, we started 4 below the x-axis, then went up to +4 above. A's absolute value is called the amplitude, so you'll have to memorize that. Now we're going to graph our basic sine function. Well, it's graphed for us already, sorry. And we're going to graph y equals 2 sine x, 4 sine x, going to be red, -3 sine x is green, and -1/2 sine x in purple. So again, before we start, I can tell right away from that coefficient, the range is -2 to +2. And again, this is going to be a dilation of 2 to the y coordinate. If we think back to our transformations unit. So our basic sine starts at the origin, rises above 1 unit above the x-axis, and then comes back down, falls 1 unit below, and then back on the x-axis. So y equals 2 sine x. It's going to start at the origin, but then instead of going up to a height of 1, it goes up to a height of 2. Right? So it's origin, height of 2, x-axis, down to -2, back to x-axis. Sine is symmetric with the origin. So now it's going to go down to -2 on the x-axis, up to +2 on the x-axis. Y equals 4 sine x. Range is going to be -4 to 4. So +4, we start at the origin, then it's going to go to a max of +4. Come back to the x-axis, down to -4, back up to the x-axis. Symmetric with the origin. Y equals -3 sine x. Leading coefficient -3. Sine curve. At 0 radians, we're at 0. We're at the origin, 0, 0. Instead of going up, we're going down to -3. And then back on the x-axis, then up to +3, back to the x-axis. Symmetric with the origin, so this would continue a nice smooth curve upward, then down, and then back up. And y equals -1/2 sine x. Starting at the origin, then it's going to go down to a height of -1/2, which would be about here, up to the x-axis, up to the max of +1/2, down to the x-axis. And symmetric with the origin. So up, x-axis, down to min, x-axis. Okay, so your homework is the next 2 pages. I would suggest that you do the same in that if you have the colored pencils, let me just get you started here. Y equals sine x, all right? I'll do black, so that's going to start at the origin at 2 pi, be on the x-axis, midway between at pi, on the x-axis. At pi over 2, it's going to go up to 1, come back down, then down to -1. Symmetric with the origin. And if you have the colored pencils or pens, if you could kind of use the same color code, blue, red, green, purple. Similarly for the cosine. Cosine y equals 1 cosine x is going to start at 0, 1. At 2 pi, it'll end at a height of 1. Midway between, get down to -1. And reflect over the y-axis for the other portion of our graph. Okay, thank you very much for your attention, and I hope you have a good day.